Me a little more time for the session. Welcome to... Thank you. Welcome to Case of the Unexplained. My name is Mark Russinovich, and I'm a technical fellow in Windows Azure. This afternoon, we're going to be talking about troubleshooting Windows, and this is the agenda that I've got laid out for us. I'm going to start by setting the stage for what exactly we're going to cover, what I hope you take away from the session, the kinds of problems that we can solve, and then jump right into some real-world cases that will show you how the troubleshooting tools, primarily Sysinternals tools, are really effective at solving kind of everyday problems that you might run into on Windows that would otherwise be virtually unsolvable. I've divided the different types of symptoms into sluggish performance, error messages, and then we'll conclude with a look at blue screens. So this is actually the 2012 version of the Case of the Unexplained talk series that I started at TechEd, I think in 2007. I'm not sure about the first delivery. Anybody remember the first Case of the Unexplained? Anybody been to all of them at every TechEd US? So a few people. So I think it was 2007, and actually you can go see previous webcasts of some of the older ones. And I recommend, if you think this is useful, that you do, because every one I try to make different. And it's different in a few ways. One is that there's different troubleshooting cases. And second, to go with those different troubleshooting cases, there's different techniques. And so this is just a subset of the kinds of techniques and tools that you will be able to use to solve problems. Let me show you how you can find the previous webcast. If you go to Sysinternals, how many people have been to Sysinternals? So, all right. Just wanted you to stretch and make sure you're awake. But if you go down to here to resources and go to Mark's webcasts, then you can see all my webcasts that are recorded that I basically catalog here right at the top, the ones that people are most interested in, the case ofs, and you can see I've got back to 2008. I think maybe it was 2008 is the first one. So I recommend that you come and take a look at those if you find this useful. Again, these are based on real case studies. Some of these have been also written up in my blog in much more technical detail than I have time to show you here. And I ask you, if you run into or solve problems with the tools, that you take the time to document them, capture screenshots, write them up, a description, and send them to me. That's the way that I fill out my library. And by the way, the library is pretty big at this point. You would think that people occasionally have problems running applications on Windows based on the number that I get. But I think it's just probably... I don't know, people making things up. So the reason that we have to actually troubleshoot is that applications themselves do a poor job of handling unexpected situations. When developers go write their code, they do it for the environment that they expect the code to run in, and this is also the way they test the code. It's supposed to be installed properly, the DLLs are in a certain location, the ACLs are set right on the folders, and so they run all their tests and everything's great. And then it goes out in the wild, and most people don't run into any problems, but every now and then somebody's got an environment slightly different, and the app then hits the case that they didn't program for, and suddenly the code goes shooting off in a direction that nobody ever looked at. And that has several symptoms as a result. It's misleading error dialog boxes that say, my favorite one, unexpected error, or the app simply crashes or hangs. So the purpose of this talk is to show you how to go underneath the hood to solve these kinds of problems. And actually you'll see that given this is like not me just saying that you can solve these problems with the tools pretty easily, but these are real people that have solved the problems. And shows you that, hey, if they can do it, you can do it. Just takes a few minutes of getting familiar with the tools and the techniques. And some of the key learnings for troubleshooting: one, understanding processes, what a process is, understanding, of course, basics of file and registry access on Windows, and interpreting call stacks. This is the fundamental tool for diagnosing the root cause of many types of problems, is looking at the call stack, and I'll describe what a call stack is as we go through here. The tools we're going to use, well, this collection called Sysinternals, I think they're pretty decent, so we'll use a bunch of those. Starting with, and this is the full list of tools that I've covered in any of the Case of the Unexplained. In this particular talk, I'm just going to use a small subset of them, but I just wanted to list this slide I basically reuse everywhere. And then at the end of the talk, when I talk about blue screens, that's when we use debugging tools for Windows. This is a part of the Windows SDK. And you can find actually that's an internal URL at Microsoft, that //dbg. We have access to the latest version, which is really cool. But you can go get that tool there. So let's get started. Oh, actually, one more thing. Now, of course, I'm going to give you 75 minutes of Sysinternals tools, but this book, which Aaron Margostis and I co-authored, published last year, is the definitive, obviously, reference. I think everything in there is pretty accurate about the tools. Covers every tool, in fact, just exhaustively. Even the least well-known tools are covered in this, and full chapters on the major ones, of course. Aaron did the bulk of the writing. I have to give him credit for that. And so you can see his name's on the cover. He finally convinced me I should put it there. So let's talk about application hangs first. This case that I'm going to show you makes use of this tool called Process Monitor. How many people have run Process Monitor? Let's see, raise your hands. Good, stretching their arms again. How many people have not run it out of curiosity? One, you're admitting it? Wow. So Process Monitor is a real-time file system, registry, network, process, DLL tracing tool. If you're familiar with FileMon or Regmon, which some people still fondly recall, then this tool is going to seem right at home to you because it presents a user interface that's very similar, although underneath the hood is completely different and way more powerful than those tools were. First of all, just this is the default view. You can see the time of day of the operation, the process name of the operation, including, for example, the description and company name of the image, as well as the path to the executable there in a convenient tooltip, the process ID, the operation, here's a create file, the path to the resource that's being acted on by the operation, in this case it's a file, command.exe, the result of the operation, and then over in the details column, additional information specific to that particular operation. In this case, it's a create file, so this will show you the parameters that went into the create as well as parameters that came out of the create. For example, you can see the disposition was open here, and you can see at the bottom there, the open result is it opened. So, and that makes sense because it was a successful operation. That's just touching the surface of this tool. In fact, this is kind of interesting because many cases, in fact, you'll see some of the cases in here, somebody starts out with a different tool and then ends up solving the problem with Process Monitor. If you look at my collection of troubleshooting cases, almost the vast majority, I'd say probably 80%, are solved with this tool. Dave Solomon, my co-author on Windows Internals, he came up with a phrase at one point, when in doubt, run Process Monitor. So that phrase has actually served me really well. When my daughter comes home from school with homework questions, I have her run Process Monitor. When I doubt Microsoft stock will ever get above $35, I run Process Monitor. And then I get so distracted in the cool things that I see that I forget about the stock. Now, those of you that have used Process Monitor for a while might not be aware of some of the most recent enhancements. One is bookmarking. I added this because Microsoft customer support often troubleshoots cases, and then they hand off the case to somebody else. They do a first-level pass. They identify interesting things in the case, and there was no way for them to really say, go to this line. So I added this. This lets you basically just say Control-B or right-click set toggle bookmark, and you can see that's now highlighted in a darkened text. If we scroll way down to the bottom and set another one, well, how do we get back to the previous one? There's menu items, or you can use the F6 shortcut, Shift F6 to go in reverse, and then we go to our bookmarks. You can save that now and reload the file, and those bookmarks are preserved. You can even apply it to older Procmon files. I made it work against existing Procmon files too, so if you've got some already, you can use them. Another enhancement that's worth talking about is that process start events now show the process environment variables as well as the current directory. These can have an important impact on process behavior. A lot of processes pass information to each other and access the system via environment variables. Let me show you a little simple example. I'll turn on monitoring now and clear the display. So I'm going to CD into Windows System 32 and set my path to TechEd Rocks. And then I'm going to launch another command prompt, which I can do successfully. Now let's CD here and try to run another one. And I get that problem right there. So if I go to the process tree, this is something that is really handy at seeing the relationship between processes. I also use it quickly to go find which one I'm interested in. It's going to be this last child, of course, of the command.exe process tree. That's the one where I set the environment variable. Here's the one where I failed to run another instance of Notepad. So if I double click on that right here in the process tree, I've just set a filter, which I'll talk more about, to just that process. In fact, I go right to the very first item that process operation that process generated, and if I look at the tooltip here, I can go and see that the path was set to tech had rocks, and that's why the thing was broken. So that's another enhancement. This first case now, let's get back to that because this person ended up using Process Monitor to solve it. They experienced a 40-second delay for IE's download bar to come up. So they went to some site, pressed on right-click download or the download button, and IE just sat there. They didn't see the bar. They could still interact with it, and then 40 seconds later, boom, it appeared. And this happened continuously over the course of a day or two before they said, hey, I should run Procmon. And in fact, they first tried, of course, running IE without any add-ons. First troubleshooting step with IE, still had the same behavior. I can reproduce that behavior with IE, so let's go take a look at it. And in the process, I'll show you a cool way to get all of the tools. Well, first, if you're not aware, there's a live Sysinternals.com right here where you can access the tools through a WebDAV share directly without even having to install them. So I recommend you check that out. But if you go to the Sysinternals Suite page, this lets you download the whole package of 70-some tools in a svelte 12.2 megabytes. And that's without using assembly language, too. So here I double-click, I say save. Oh, and you know what? I forgot to say, oh, I'm capturing good. And at this point, the yellow bar should pop up instantly saying status of the download, but nowhere to be seen. So where is it? It's coming. Everybody yell boo. It's Aflac or Aflac. All right, it's good. Okay. Now it's asked me where I want to put it, and then the bar is going to come up. So that was, I don't know, a minute and a half. I don't know, it seemed like forever, didn't it? So we go back, and we just want to look at IE. Now, the problem with setting a filter for IE is that we can't just go find, IE right here and right-click. Well, we can't just go right-click and say IE right here, this process ID. We can't do the bullseye, which is another way to set the filter. If I do that, what I've done is set a filter for that particular IE process. And if we look at the process tree, we'll see that IE is more than just one process down here. It's a tree of processes because it's got this broker process and then child processes hosting tabs. So for that, I'll say Control-R to reset the filter, and we'll set just filter on IE, so include Internet Explorer. Now, how do we go find what was causing that delay? This is kind of interesting because I'm following the steps that this person did. Everybody solves problems differently, and I look at some of these cases and I said I would have gone in a completely different direction. But the interesting thing is they still result in somebody finding the solution. So that makes it just worthwhile that somebody really did solve a problem this way. So what they did was went to the Tools menu bar, and they did count occurrences. This is a little dialog box that lets you see how many of a certain result or path or any other value in any of the fields occurred in the trace. And the one that's most powerful, most interesting when troubleshooting is result. And I say count result, and now you can see the kinds of errors that show up in a typical trace. And it really, part of troubleshooting is really getting an idea for how the system works under normal circumstances. Because if you don't know that, you're going to look at this and go, oh, crap, my system is like errors all over the place. I need to go get a registry fixer or a DLL fixer someplace to fix my system. But in fact, almost all these errors are common everyday occurrences. There's one in here, or there's two in here that are really troubleshooting kind of errors where you can go investigate for different kinds of symptoms. But I think probably looking at this, you can guess which one is the problem here. Anybody see it? Access denied? How many people say access denied? How many people say bad network path? How many people say buffer overflow? And that's not a security issue. So there's lots of people that still haven't raised their hand. How many people have no idea? How many people just don't want to raise their hand anymore? All right, so it's this one right here, bad network path. And access denied, that's the other one where if you run into problems, a lot of times it's access denied. So that's worth investigating too. In this case, it's this one. This one is pretty rare, actually. So when you see that one, let's set a filter for that. You can just double click on this one, and I've just set a filter. Let's go see what happened. Well, Internet Explorer is trying to open an obviously bogus path. Nobody names their servers foobarred. So, and bad network path. Actually, I just made this up. Now, where is this coming from? If I do a Control R to put the filter back, to reset it to its defaults, we know we're interested in finding out where foobarred is coming from. So let's go to the top and search for foobarred. Wait, did I mistype that? Great. Did anybody remember what it was? It really foobarred? Foobarred. Oh, wrong direction. Yeah, sorry. I got that from the bookmark search. All right, foobarred, and look at that. Internet Explorer is first doing a reg query key value of this path right here. HKey current user software, Microsoft Internet Explorer, main, default download directory. And what's the result? Foobarred Baz download. So it's getting it from there. If we right click and say jump to, we go right to that location, default download path, right there, where it came from, and now we can just reset that or whatever and fix the problem. Now, Internet Explorer would actually, at that point when it popped up the dialog, had given up on that and was going to let me pick a different place. But that's not the behavior that this guy ran into, which is slightly different, yet he's troubleshooted it or shot it, I don't know how you say that, in the same relative way. Here's his dialog boxes. The first thing, he saw the bad network pass. He didn't see an access denied. He double-clicked on that, and he saw references to his Media Center PC, which was turned off at the time. So where does that reference come from in this case? He didn't bother double-clicking and doing what I just did to go look in the registry. He said, he basically looked around IE and said, why is it accessing that? Oh, maybe I downloaded something to that previously that it remembers. And there in the download dialog box, you can see this path to free sample M4 MP3. Yeah, I'm sure that didn't carry anything bad with it. But you can see the path there. And so once he cleared that out, the problem went away. This next one actually was one that was widespread. Anybody run into this one? Back in October, PayPal was sending out emails to people. You'd get this payment confirmation or debit confirmation or deposit confirmation, and Outlook would just hang for 30 seconds a minute while it was looking at that email. And this caused a flurry of people posting on forums, news groups. Well, this particular person, I think, might have been the first one to solve the problem, at least from outside PayPal. Oh, by the way, I think the interesting thing about the previous example is that it's a sluggish troubleshooting case that didn't involve Outlook. Now this one does, which is just kidding. I can't help it. You know, Outlook's my friend. I live. So, any case, yeah, me and Outlook have gone through a lot together. I'm sure you have too. So Outlook hangs on this, and what he does, he takes a different approach than the other guy did for a similar kind of symptom. Let's go take a look at his file, which is sitting here in this directory. So there's the clue somewhere in this list. It's filtered already down to Outlook. Somewhere in here is the clue for why Outlook is hanging on that email. I could do count occurrences and that wouldn't even reveal it. Well, it actually might. But the way he did it was he said, I'm going to add this column duration, which you didn't see added by default in the process monitor when I first brought it up. But this duration column shows you how long a particular operation took. And again, their hint is in there. The clue's in there somewhere. Some operation took a long time. We're not going to go digging through the 3,000 events to find it. Instead, what we're going to do is set a more complex filter here. We're going to say duration is more than, and let's just pick 1 second just to see if we can spot anything that sticks out. Say OK, and there it is. A create file to this bogus path with an, well, there you go. There's an access denied. So this is actually a server that was on the web, but was locked down so that nobody could access it except for them. But somehow Outlook is referencing this thing. Why is Outlook referencing this? So that was his next question. So he turns back to the email. And first of all, he does a web search to see if he can figure out what that DNS name, who owns that. And it's a company called Omniture. Actually, while I'm here, let me show you another little tool. Another way that you could see this is using the Sysinternals whois command. And then I can do copy, paste, and then say whois. Whoop. Oh, this is the bad command prompt. Whois. And then, OK. Oh, that one already said it, too. Yeah, all right. Whois. And then you can see that it's Adobe. And you can all give them a call right there. So he didn't actually call them, at least not at first. What he did was go back and look at the source of the email, and what he found in the HTML, because it was formatted HTML, is this snippet right here, which is the notorious 1x1 with a link there, a URL. Now this obviously, if 1x1 means people aren't supposed to see it, and it's referencing something else. Obviously PayPal is using Omniture to track how people are reading their PayPal emails, like how many people open their emails. Well, they just count the number of hits on this particular URL, and that gives them some kind of idea. And also they can see who did it because they're passing in that, probably the parameters there, some ID that tracks you. It's all for your own good, though. Now, what happens, though, is Outlook looks at this thing and it interprets it as a file path, and it hangs. This guy contacted Microsoft Security because he thought it might be a security issue. Of course, we're going to say it's not. And so then he contacted PayPal, and they said, yeah, it's a problem, and so they fixed it. And you can see still the remnants on the web of this thing. Whoops, that's the wrong. Oh, I actually don't have that URL. But you can go up there. See, now PayPal, what they recommended to him was to do this, which is to map that to a null address, and then and this went all over the internet for how to deal with this problem. Actually, there was all sorts of, as I was looking at this, there was all sorts of interesting solutions to this problem, including screwing up your Outlook configuration pretty well to work around it. But the bottom line is, he used Process Monitor. Within a few minutes, it led him to the clues that he needed to figure out what the problem was, and then he was able to go and find a workaround. And by the way, there's a lesson in troubleshooting cases like this and others that you'll see where you think troubleshooting, I'm going to solve a problem. I'm going to go find the root cause, and I'm going to fix it. And that's not really what troubleshooting is all about. Troubleshooting is about making forward progress, getting past the problem, and that might just mean working around it, not actually fixing it. So in this case, he worked around the problem because he couldn't fix it. Now let's take a look at another few cases. This one is a sluggish performance section, and so we're going to start with Process Explorer. This first case, the user uses that. How many people have used Process Explorer? All right, I know. So I'm not going to make you do it again. Now, Process Explorer, for those of you that might not have been aware, it's like people consider it a process or a task manager replacement. You can literally replace Task Manager right here with the Replace Task Manager button. And so now, what's your favorite way to launch Task Manager? Control-Shift-Escape. That's mine, too. And let me close this and Control-Shift-Escape. And OK. What happened? Control-Shift. Oh, it's not Function-Shift-Escape. Control-Shift-Escape. There we go. Now, it launched with limited user rights, so I'm going to elevate it so we can continue. But that's showing you how Process Explorer can replace Task Manager. So let's take a look at Task Manager. Actually, some more things before I get into the review of the display. One of the things that I always do is hide it in my tray and then use the you know, the funky, yeah, I want to customize my thing so that it shows up all the time. If I was outside of Microsoft, I probably would have just made Process Explorer hack this so that it would just show up all the time, but now I've got to play by the rules. So, and then what you can do is spot excessive CPU activity. The tooltip will show you what's the biggest consumer at any point in time, and then it's an easy way to launch it as well. Let's take a quick look at the UX. Most of you are probably pretty familiar with this. You get process tree, shows you parent-child relationships. Any process that's left justified has been orphaned. No? No sympathy for the orphan processes? All right, moving on. Description, company name is pulled from the process version resources. So it's not like Process Explorer has some database of things in it. And down here you can see the processes that were launched in my account because they start with Explorer, and that's my shell. How about the color highlighting that we're seeing, which you don't see in Task Manager? Anybody know what the blue represents? Boy processes. Right? I told you the other day that pink is girl processes. And so, no, actually not. Blue means it's running in my security context. Pink are hosting Windows services, and you can see those in the tooltip right there. I'm going to assume that you can dig further into it, and we're going to show some of the features as we go along here. But to kind of move along, let me introduce to you some features that you might not have been aware of that I've added over the last, say, 6 to 9 months. One of them is GPU monitoring and support for Windows 8. So I'll go ahead and demonstrate GPU monitoring. GPUs are becoming such an integral part of systems, I felt that Process Explorer just has to show that as a primary resource. I'm going to run a little tool that hammers the GPU, and we can watch what happens in Process Explorer. So benchmark, and you can see this thing is chugging along pretty hard. One of the system information graphs is starting to show activity. Maybe it's not quite enough activity, so let's crank up the resolution a little more, 1024 by 768. And now let's see. Anybody see which one it is? It's this one over here. If I move the tooltip over it, I'll see that the GPU is being consumed by, well, DWM now is consuming a lot of CPU because it's zooming, but MSI Combuster. And if I click, I get GPU usage as well as RAM usage. And there you can see Combuster. Yeah, thanks. And on Combuster itself, we also have GPU, per process GPU usage broken down. You can also add columns, of course. So that's one of the new features. And another one that I just introduced a few days ago, actually two features. One is process timelines, and the other one's auto start locations. Let's go add that. And process timelines. And start with auto starts. I integrated auto runs engine into Process Explorer, so it scans the system asynchronously while it starts, and will show you where an image is registered to auto start. And you can see services like this configured in the services key. Why is Explorer launch as my shell? Well, if I can move the mouse to it, it's because it's the shell, which makes sense. And let Process Explorer come back. And for services, like service hosts that are hosting multiple services, well, there's an IPsec policy agent in here. If we open the DLL view, I've added the auto start location to that as well. And if we sort by that, you can see where these guys, DLLs, are coming from, including the service itself, coming from policy agents. So that's, I think, a pretty useful troubleshooting feature. And then next is the process timeline, which is like process monitors process timeline. It shows you process relative lifetimes, so you can easily see who's been around for a while and who just started. And that was introduced last week. So let's move on to the case now that uses Process Explorer. This one, guy, administrator, system administrator, had this web server where jrun.exe had occasionally spiked to consuming a whole core on this dual core system. You can tell it's a dual core system because when you spike to 50%, that means you're using one full core out of two. he never bothered to try to figure out what it was. It was one of those things where, well, things work kind of well enough, and I don't really know how to figure out what's going on anyway, so I'm just going to let it be. He came to one of the Case of the Unexplained talks, and then he saw, hey, I can actually go figure that one out. So what he did was looked at Process Explorer and looked at the threads within JRun to see if he could spot anything. Now, this brings up the difference between a process and a thread. Processes don't actually execute on the CPU. It's the threads within the process. So if I look at just a Explorer, for example, and I go to the Threads tab, this will show me the threads that live in it that actually make up Explorer's usage of the CPU. We can see Explorer using some. And one of the things that Process Explorer will show you are start addresses, where the thread was programmed to begin its life. If you've got symbols configured for it, which you can configure in the options, and that's described in debugging tools for help, if you look for how to configure symbols to point at the Microsoft public symbol server, then all Microsoft images that are, not Office, will show up with symbols. And then you can get more hints about where they might have started their life if they're part of the operating system. So what he did was said, okay, I'm going to go take a look at that. And this is what he saw. The thread start address, it didn't actually reveal anything in this case. If you look at all of those are generic start functions in the Visual C runtime, in the C runtime library. So it's actually, he felt he had to look deeper to see what the threads were all about. Why are they consuming CPU? And for that, he turned to the thread stack. Now, what's a thread stack? A thread stack shows you the call history of the thread at its current point of execution. It shows you both within a DLL, how the functions broke down within the DLL, where one function calls another function as part of subroutine nesting. It also shows you calls across DLLs as well. And by looking at that, you can see, we're using Process Explorer stack dialog, a snapshot of where that thread is right now. And if you let it finish doing what it's doing back to the beginning of where it initially started executing, which functions it would pass through on the way back up. So let's take a look at that in here. So this shell WAPI thread proc, what's it doing right now? Well, it's sitting here. This is the beginning of its life. So it called some just standard operating system thread start functions. Here's the worker thread begin function. Here's Explorer now. And Explorer's tray message loop is what is executing. In fact, it's probably displaying Process Explorer's icon, which is why we see it executing on the CPU. And then it's sitting here waiting right now for a Windows message. We can see it heading up into the window manager, user 32. So that gives us a little insight into what threads are up to. What he did now, double-clicked, and this is what he saw. This DLL right here, anybody know what that is just by looking at it? And by not looking at the slide up there? There it is. It's the ColdFusion DLL. Anybody still use ColdFusion? Yeah, one person? Why? No, just kidding. So there was no obvious reason for the CPU usage here. This is where he'd gone down this path. He had some clues now, and he turned to what tool now? Let's all say it together. When in doubt, wait, no, yeah, but no, let's do the whole thing. 1, 2, 3. When in doubt, run process monitor. That's pretty good. We'll get better by the end. All right, so let me pull up that. Log file right here. So here's the full unedited log file. Now there's a lot of stuff in here. What he did was set a filter for JRun just to see what it's up to. But I'm going to show you another way to zoom in when you've got a lot of things going on, like who's the busiest. It's the tools process activity summary. And at this point, I can see by sorting by file, by CPU, by registry. I see kind of timeline graphs as well. Now look at registry, kind of sticks out here. This guy, 21,000 operations, and it just happens to be JRun. If I double click, I get this dialog, which shows me JRun's execution over time. But so it's JRun. There's some other tools up here, like we know it's registry. What registry keys are being hit? Let's go to Tools, Registry Summary. And almost all of those 21,000 operations are right here HK Local Machine Software, Macromedia, ColdFusion, current version clients. Just like the other dialog box, I double click and I've set a filter for that. And so what is that key full of? This. A bunch of names with big numbers and lots of indices. We're in index 56,000. And the trace goes on, and this is just a subset of the hang, so hundreds of thousands. So he does a jump to and tries to open that key in regedit, and you can see regedit doesn't like that. So literally minutes later, regedit would finally open, and there it is, full of that stuff. So he does a search on the web, and he finds this article. Did I close that? No. IE. This, how to configure client variables in ColdFusion, and it says, yeah, you can use the registry, but yeah, we don't recommend it. So why that's the default, I don't know. Actually, whoops, I didn't want to do that. Here, where does it say? By default, it's in the registry. In most cases, however, it's more appropriate to store the information as client cookies or in a SQL database. So why didn't you just do it that way? And maybe that's why people don't use ColdFusion anymore, I'm thinking. So he opened the dialog box and he flipped it over to cookies, and the problem went away. Let's get into some error messages now. How many people have run into a bizarre error message in the last hour? Yeah. Anybody in the last 15 minutes? Yeah, somebody? So these happen all the time. I get them all the time. I told you my favorite one's unknown error. This one, though, is up there because this person sent it to me, and I'll try to read this for you. La acción no se puede completar porque otro programa abrió la carpeta o uno de sus archivos. I actually was born in Spain, so I'm cheating. So that dialogue, I think everybody picked up what that was. That's actually one of the most common dialogues you run into in Windows. And I've got a case where I can run into it right now on purpose. If I go to case of, and I say, well, this directory right here, can't delete. Well, here's the English translation in case you missed it. It's opened by another program. Well, what other program? Thank you. And we can do a handle search. And we can say, can't delete. And do a search. And then click, and there it is in the handle table, command.exe. We can, even if we want to, close it. Although we get a nice error warning message. Forcing a handle close can lead to an application crash and system instability. Normally, I'm not one to care so much about those kinds of things, as you'll see at the end of the presentation. But what do you think? Should we close it? Yeah? No, let's not. Okay. Can do that. Okay, so we close it. What's going to happen now? Do you think we'll be able to do a directory listing? Oh, there's what happens. So it kind of looked like it was working, but it's kind of sick at this point. And I think we'll just put it out of its misery. There. Well, actually, there, it went away. So that's handle searching for the infamous file in use. Now, what he did was he used Process Explorer to see what was going. He looked at to search to see what files were open and saw that the thumbdb file here in the directory. Oh, sorry, I forgot to even set this one up. Users were complaining about seeing this dialog, obviously Spanish users. And retrying would almost always work, but it was annoying enough that he kept getting support calls. So he finds a system that it reproduces on, and he catches it right in time, Process Explorer, and sees this file in use. And then he concludes, after he does this little research on his own and on the web, that if thumbsdb is present, Explorer opens it and does stuff with it, and it doesn't close it in a timely way. It's not even clear why not, but he managed to find a group policy setting. There, should be obvious what that one is. Where he could go and say, I don't want thumbs to be scanned. And this one, this one is like this long-winded. Everybody, in fact, somebody came up to me 2 days ago and said, I run into problems with thumbs here. and running into this on Windows 7. So apparently, we've just decided that it's going to be fixed in Windows 8. And in fact, any annoyance or bug you see in Windows 7, it's going to be fixed in Windows 8. All right, let's take a look at another one now. Now, this one, a particular user complained that the Details tab of the Explorer properties was missing on the PowerPoint show files, but not the PowerPoint show Office 2012 files. Now, obviously, this person is in marketing and just looking for an excuse not to get any more work done. But this is actually something you can see on your own systems. If I go to Computer, and if I go to my little folder here, and I go to Missing PPX Details, I've got two files. One is a PPX and one's not. I'm going to reset Process Explorer, and we're going to fire up, or Process Monitor, and we're going to fire it up and capture a trace of the execution of me looking at the properties of the PowerPoint show file, and then compare it side by side with me getting the property or looking at the properties of the 2012 version, and then see if we can find the difference. This is one of the also extremely powerful troubleshooting technique. If you can get into a situation where it works on one environment and it doesn't work on another environment, where you can compare the two, that is actually kind of a big help in narrowing down what could be going wrong versus just searching through and trying to figure it out. So that's exactly what we're going to do in this case, and that's exactly what this person did when they ran into this. What we're trying to do is say, how can I, first of all, why is that functionality missing? And then if it's missing, how can I add it back so that my marketing people can get working again? So let's go look at the PPS first. If I do Properties, well, you can see if I move to the Details tab, that I don't see the nice things where you can see who made the thing and where that came from, and it's the marketing people that did it. So let's now save that to the desktop. And now what we're going to do is clear this, and then go back and get ready to do it again on this one, which is just an empty 2012. And if we go to Details, you can see that we have the nice little descriptions and the authors and the revision number and all the things that the marketing people love. Now if I close that and I freeze this, now what I'm going to do is use one of the coolest features, I think, of Windows 7, that. Arrow snap. Long live arrow. Now, I think some people got that. Whoa, somebody got that. That's timing right there. Okay, so what are we going to do? The first thing is we got a bunch of stuff here. Let's get rid. Well, we know it's Explorer that's actually showing that dialog box, so it's likely Explorer. But I'm not even going to bother with that. I'm just going to search for the file extension, because let's just see where that thing starts becoming interesting to the system. And actually, that's a file system API right there. C demo, case of missing. That's actually, I caused that. How about this one? Okay, here's one. Promising, reg open key for software classes PPS, name not found. Let's go back to the other side. And I apologize because Process Explorer, the way I've implemented the tooltips, causes the list view control sometimes to slam the scroll bar to the left, and so I'll have to reset it. So that, apologize if that happens while I'm doing this. But here's the, well, is that the one? Well, that's not it. That's a different thing altogether. And here we're lined up now. And this is what you kind of generally want to do, is line up between the two traces to see if you can spot differences. So you can see the spasming of the list view control. But you can see that we've lined up, and if you look below it, it's not a perfect match side by side. And this is actually not the worst case scenario. It's really nice when you just go check, 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 match, match, match. Ooh, this guy went off in the wrong direction. What's the last one it had in common? What's the, and then you can really zoom in on it. But I found in many cases that systems are so subtly different, with different registry keys in the mix and different DLL add-ins and things like that, causing enough to get thrown off, that what I do is I look for shapes and kind of try to match up shape-wise. So I'll go down the trace. Oh, we've lost the shape match. Oh, but we've regained it, so it's OK. Oh, we've lost the shape match, but we've regained it. And that's kind of what we're going to see here. So I'm going to press down page. And actually, one of the things that I can do is just, for the sake of time, get rid of the time column, get rid of the process name column, get rid of the PID column, and then that way we don't have to deal with that jerking around, and do the same on this side. Time, which other one? Process name and process ID. And now we can kind of work unobstructed. So where were we? We were right here and right there. Let's scroll down a little bit here. Scroll down a little bit here. We've lost our shape. We've lost our shape. Can we get it back? I don't know. It looks like we've lost it completely. We're not supposed to do that, actually. Let me do a search again here on this side. And on this side. So this is the challenge of doing it live, because the traces are always subtly different. Oh, you know what? It would help if I got rid of everything but Explorer, because I'm probably looking at other stuff mixed in. So let's go ahead and do that while I'm here. Explorer. And that will help us out a lot. I should have just done that at the beginning. And Explorer. OK, now let's go back, resync, and resync. And here we are. OK, now let's take a look at the shapes. They still don't match, which is OK, I guess. And they matched before. What is doing this? Process. Oh, you know what? I didn't set a filter for Explorer on this side. Did I? OK. Try number 3. I think 3 times the charm here. OK, now, are we going to match? No. OK. Wait a minute. Something funny's going on. I think we still see host process. So I've got screwed up filters on this side. Oh, in fact, it didn't even include Explorer. All right. Hold on one second. Before I admit this is a bug, let's add this back and say, all right, Explorer. There. OK. There. Now do we see a shape match? Do you? It's better? Yeah, it's improved. Oh, there's current versions. I saw current versions up here. Oh, there, current versions. We got a shape match. How about here? Oh, slideshow 8, slideshow 12. It's looking good. Oh, look at this. We're matching up better. Matching up better. And, yeah, that's what I thought. Actually, can you see it? Anybody see? It's there. Notice this right here. HKey current user, software classes, system file associations, PPS on this side, name not found. That's a match with that right there on this side. In fact, I've lined them up coincidentally right next to each other. Look at the next one. Name not found on this. HKey current user, or HKey classes root system file associations, PPS, name not found. And on this side, it goes off in a different direction. And if we scroll down a little further, they're going to veer off in wildly different directions shortly. So let's go back and see what's going on with those parts of the registry. On this side, I'm running with admin rights. On the other side, I'm not. So let's do a regedit jump to, because they're close to each other anyway. And what we can see is a whole bunch of stuff here in the PPSX key, like extended tile info, full details, info tip, preview details. And we know that there's not a PPS key, which would be right before this one. So it's missing. So what do we want to try to do? And this is what he did. He said, I wonder if I just export that and then change the path and then re-import it back. You think that'll work? Yeah, it's kind of obvious at this point that I'm setting you up for that. So let's go try it. And here's I've already made the reg file. Here it is, and you can see that the only thing different is I've set the path to PPS. So now what we're going to do is double click. Are we sure? Yeah. And let's see. Let's go back to our folder. And drum roll. Here we go. Woo. All right. So we've managed to eventually get through that. Now what he did was, this is his trace, actually compared side by side. And he did this on his own. He did this shape shifting matching thing and nailed it down to right there. These are the things that he highlighted himself. So he highlighted, if you look, this right here, the PSSX file associations key success on that side, name not found on that side. And then he saw this reference to full details here, name not found on this side, and success on that side. And then so that's what he did. Now, the case wasn't completely done for him. Wasn't completely done for him at that point, because the marketing people, when he gave it back to them that way, they said, wait a minute, we can't edit those settings, so we still can't get any work done. So he had to do it again, and he did it again. That's another reference to HKey classes root PPS missing another one, and repeated the import export, and now you can see the no edit and the fixed. Finally got the marketing people to go find some other excuse not to get any work done. So that is the example of the side-by-side, which I find many cases to be the key to getting a clue to solve a problem. Let's talk about blue screens now. How many people have run into a blue screen in the last 6 years? All right, how many people in the last week? Anybody in the last week? Wow, how many people in the last day? Is anybody raising their hand? Yell if you're raising your hand. Wow, I thought I was going to be able to ask that question and have nobody raise their hand. I was hoping, but we still have hardware problems. That's what it is. It's all hardware problems. So, how many people have seen a blue screen out in the wild? So quite a few of you. If you see one, send them to me. The New York subway? That's a good one. I've got some to share with you. Yeah, like my bags are going to show up now. There's the New York subway. This is the thing that you buy your tickets at. Anybody recognize the version of Windows on that blue screen? They're still running that today. So anybody that wants free tickets, let me know. So, how about your billboard? CompUSA's bestseller. No wonder they're out of business. Concert. Actually, I found out that somebody sent this to me, and then I found out that it's actually some techno DJ that actually puts the blue screen on there on purpose to be like hip and cool. So the blue screen is pretty hip, I guess. Anybody recognize that guy? Dave Solomon, my co-author in Windows NT Internals, and he's at the airport, and this is where actually I don't know where he is. He's at a hotel. That's a hotel. You can see kind of the lobby back there. But I guess he was walking through, saw it, figured out what it was, and then had his wife snap a picture because he was so proud of himself. Flight to nowhere. So this is a gas station. Now, I don't know if I can blame the gas station. Actually, those are unconnected, but I thought it was funny because that picture was taken in the Microsoft parking lot. And so I just had to get that in there. So here's a mall. Conference room at Microsoft. We can't get anything done because we can't even get the display oriented correctly. It's the most popular Surface app is one where you can make ripples in the blue screen. This is the most publicly visible blue screen ever seen by more people than any other blue screen, I guarantee you, in the history of the world. Does anybody know where this is? Yeah. So you might have seen this. There it is. Opening ceremony, Beijing Olympics. I think, what, it was 1 billion people watching this. Good advertising. Paddington Station, train to nowhere. Definitely not going to Harry Potter land. Would you like a blue screen with that? And just to show it's not just us, but actually I find it kind of comforting to see all of the places in public. It's like, oh, I didn't know that thing ran Windows. That's pretty cool. So I tend to look at the bright side. Now, when you run into a blue screen, most of the time it's like reboot and just hope that things are going to get cool again. But with just a few minutes, you can actually go see what might have caused it. And it's worth doing. It's kind of hit or miss. But if you can figure out that 1 of every 5, then it's probably worth the literally few minutes it takes to go and analyze a blue screen. Now, the blue screen dumps, of course, get sent up to Microsoft, and we analyze them, and we go and we have humans figure out if there's a fix, contact vendors, then eventually a page might go up, and eventually you might get a fix. But there can be a long lapse, especially if you're running more tail-end hardware, tail-end device drivers that don't show up in the big stack of things, what most people are hitting. Then you might not ever get a solution automatically delivered to you, and so that's why this is still useful. This is the online crash analysis. You've seen this sometimes, or a lot of times it doesn't know the cause. It used to tell you, now it just is like, I'm not even going to let you know that I don't know, because that just makes me look bad. Now, the first step to finding the dump, or analyzing the dump, is to get the debugging tools for Windows, which I've already told you. You can go to Microsoft and go to SDK downloads and get the debugging tools, or the Windows driver kit. The second thing you need to do is actually go figure out where the dump file is. Now, over versions of Windows, there's different sizes of dump files created automatically, and they go in different places, and so you have to memorize this big matrix. Actually, there's a rule of thumb. Go into the Windows directory. If there's a memory.dump file there, open that one. If there's no memory.dump file, then go into the mini-dumps directory, and there'll be mini-dumps, hopefully, of previous crashes, including the most recent one that you're interested in. Just open that one. So that's all you need to remember about where these things are. Now, what do you do? Let me show you a case. Well, let me introduce the case for you, and then I'll show you how you analyze a dump. This case started with a Hyper-V cluster starting to have random crashes. And this is another situation where the person had come and seen the case of the Unexplained, saw how easy it was, and so they said, oh, I'm going to go take a look at it myself. And let's go see what he saw, because I've got that dump he sent me. I'm going to open up WinDbg. I'm going to go to File, Open Crash Dump. And this is the Hyper-V BSD. It's a mini dump. What this is going to do is load kernel symbols. You've got to configure the debugger to point at the symbol server, which you can see I've done that right here. The public symbol server, as I mentioned, download symbols, the same thing you do for Procmon and Process Explorer. And then further down, it says bug check analysis, and then bug check 200, the dreaded 20,001 bug check, right? Nobody knows that one? Well, what is that? The dreaded hypervisor error. Hypervisors encountered a fatal error, which is bad if you've got multiple virtual machines. It's really bad. It's like more than 1x bad. And then a stack. So the recommended troubleshooting is look at the crash dump stop code in human English. Maybe that gives you a clue. And then always look at the stack trace over here that it dumps out for you. In this case, what we're seeing is the most recent, which is just a call to crash the system, because that's what happens. Anytime you actually get a blue screen, the system's healthy enough to do that, which is kind of good. Instead of a hard hang or a situation where there's no blue screen at all and no dump file to look at, this is actually better than that. And here we can see the system saying, I'm sick, something's wrong, let me call this. And we can see that this is a hypervisor, looks like a hypervisor driver right here. And then these are actually parameters. So this isn't actually telling us much. If we see that 2000, 20001, that is the stop code. Most of the times, those you'll see in stack traces, the driver is calling each other's functions and calling into the kernel and then running into the problem. So what did he do at this point? Well, there's not much to do at this stage other than to turn to the web. So he sent me this screenshot that he'd actually binged. And I said, that's really cool that you use Bing. And he said, actually, this is a new machine, and I haven't changed it yet. So. But what he found when he did Bing it, because Bing is actually pretty good at finding stuff, he found this article right here, which said, it's 2001 stop error when you start a Linux VM in Windows Server 2008 R2 SP1. Well, okay, like, obviously. No, I'm just kidding. Now, what it does say, there's a hotfix down here. Hotfix information, so this was a bug. By the time he'd run into it, it already was known, and he was able to go download the hotfix and fix up the system. And we can see there's the file right there that we were just looking at with the hotfix in it. So literally, 5 minutes after he ran into this, boom, solution, boom, no more random crashes on his Hyper-V cluster. Actually, that's the fact that he used Google was the sad part right there. Now, how about this one? An admin updated GFI backup program from the 2009 version to 2011 version. And what started happening then is every time that he'd do a backup of the server, boom, blue screen to a network location. And it would just happen every single time. He's like, this is one where he was completely stopped. It's like no server backups or go figure out what the problem is. So let's go take a look at that crash dump. I'm going to do Control D, which is the shortcut for opening a crash dump. And let's open this guy up. And I'll do the Analyze-V, and let's see what it tells us. So first of all, it says page fault and non-paged area. This is really actually one of the most common kinds of stop codes. IRQL not less or equal is another one. And it tells him that it's probably caused by this guy, ncfsd.sys. Now, what is that driver? Well, he goes and does a web search using Google, and he runs into this. Yeah, it's an NCSFD error. Well, here's what you should do. Download this DLL fixer, and everything will be taken care of. So that's Google for you. So what about the second hit? He looks at this. It says the second hit said, crash could be the result of low disk space. Look at this. List of file allocation damage, damage password list, damage or incorrect version of the NSFD file, damage registry, hardware CPU overheat. The only thing that's missing on here is my computer's mad at me. So, but he did the low disk space, he freed up some disk space, and it just took longer to get the crash. So then another hit, finally he stumbles across this one. What is this? Well, it's the Novell client for Windows. And so he disables the Novell service, the problem goes on, so then he's just like, well, I don't even use that thing anyway, so we uninstalled it, and the crashes went away. So eventually, again, just with a few basic, open the crash dump file, look at it, and then do some web searching, he was able to get past the problem. So that, actually, I ran a little bit fast. So you know what? I'm going to throw in some bonus cases. Let's do that. I was afraid that I'd had too much material this time, so I trimmed some so I could have put it back, and I've got the other cases right here in the unused cases. And let me tell you about this one. This is a case where a person was installing a piece of software on their systems using System Center Operations Manager, or Configuration Operations Manager. So it was going and doing the. You want it to be over? Okay. So he was doing this remote install of his systems, and it would fail to install. So he catches a procmon file. Well, here's the error message that he got from the installation. Location is not available. And you can see Windows System 32 config system profile desktop refers to a location that is unavailable. So he's saying, what the heck is that? So he creates this. He goes into Windows directory and creates system profile desktop. Runs it again, still gets the same error dialog box. So now time to pull out process monitor. So that's what he does. And this is filtered down just to have path references to the word desktop. Now there's something different about this path than the one in the dialog box. Anybody recognize it? Yeah, so what's going on here? This is a 32-bit process being installed on 64-bit Windows in the context of the system account. How do we know it's the system account? If we go to process, we can see that it's system. So under normal circumstances, if you installed this as an admin, the user profile would be over sitting in users. And the file, that path does not get virtualized. But any paths into the Windows directory, Windows System 32 directory, if you're a Win32 program on Win64, you get redirected into syswow64. I can show you an example of that by just running the 32-bit notepad. Let's do that, and we can watch, see Windows syswow64 notepad, and I'll fire up process monitor to watch as notepad opens files, and we'll see the references to different locations that don't, where we think we're looking at 32-bit Windows System 32, but we're actually looking at 64-bit Windows System 32. So let me add back the process name here so we can see what we're after, and do my bullseye filter on Notepad. So we're now just looking at Notepad, and then I'm going to navigate in Notepad to what I think is Windows System 32. So for all intents and purposes, I think that's where I am, but where am I really? If I go back to here, I am deep in the heart of, let's get rid of the registry APIs. I'm deep in the heart of Windows syswow64. There you can see all of the syswow64s. So what's happening is it's the file system redirection. I could actually drop a file here, and then the 64-bit notepad wouldn't find it. So when he was armed with that, what he did was simply go back now and create a syswow64 path to desktop, and then the problem was solved. Okay, so that's the bonus one. Why don't we start to wrap up here, because I've got a few more things that I'd like to share with you, including colorful blue screens. And actually that smiley face that I was using, this is the Windows 8 blue screen. Has anybody seen it? Yeah, so it's cute, isn't it? So it's to put, like, makes you forget that you're upset that your system's crashed. It's like, oh, that's such a cute little sad face. I don't mind now. But I think actually the way that I designed the blue screen was even better, and that's using a tool called Not My Fault. And before I show Not My Fault, by the way, I wanted to mention that, that Not My Fault is a tool that's part of Windows Internals that's aimed at showing you different ways that the system can crash and how to diagnose them using the debuggers. And that's going to be an expanded chapter in Windows Internals Part 2. Let me go and pull up Not My Fault. And this is a case where I've got to actually show you physically my system. So I'm going to unplug it and turn it around to show you what's going on, because it doesn't come up on the display. Or maybe it does with HDMI. We'll see. So not my fault. You can pick the colors that you want the system to crash in. And there's an Easter egg in here, which is black. Whoops, colors black on black. Okay, here we go. Ready? And isn't that prettier than the smile? So to wrap up here, what I hope you take away from this is I didn't give you the recipe, and I think lots of people have asked me over the years, what is the troubleshooting recipe? Step 1, step 2, step 3, boom, I've got my answer. That's just not the way it's going to work. Systems are so complex, there's so many variables involved that there's no one-shot solution. But what I hope you took away was knowledge of these tools, knowledge of the skills, things like side-by-side compare, the filtering, how to identify different processes, how to look at call stacks, that will lead you down, if not to a solution, at least to a workaround. So remember, please, if you solve any cases, please send them to me, and I can add them to the collection to share with everybody else. I really hope that you had a great Tech Ed. I hope you have a great party tonight, and I hope to see you again next year at Tech Ed. Thanks very much.